Hello everyone, good afternoon. Welcome to this session number 315, and I will continue with this problem. In the previous session, um, I I had a few comments where mentioned that this problem can be resolved using the topologic sort. Um, in I start this topic, and right now I will try using this algorithm, in special the can algorithm, and but for first let me try to explain you how it works, and next to I will try to implement here. Yeah, well, um, this and this. Okay, got it. Now I will increase. Okay, I think that it's a good size. Okay, now basically in the topologic, I don't know which is the right version, but in this topic you have a resolve using two techniques or two algorithms. The first is the DFS, but the problem with the DFS that we can detect when well, it's not prepared for graphs with cycles, and with the can, yeah, with the can you can detect this. Now okay, the first point is that you need, for example, you need know how many nodes you for example, in this case is 7. Yeah, it's important this, and it's equal 7. And the next is that create a map here with this register, for example 0 1 2 3 4 5 8, okay, and 6. And obviously this is a list. Yeah, and next to is for each this array, and put the values. For example, a it's equal array in the index 0. Do you imagine that the array, because this is a matrix, and if we apply a for each, we can call this item as a array, and b it's equal array in the index 1. But in this case we should save in the positive way. For example, in this case is 1, and this is 0. We can say 0 add the 1. Yeah, in this case is in the register 3 add the 0, in the register 2 add the 0, in the register 2 add the 3, in the register 5 with the number 5 add the 2, in the 5 add the 4, in the 6 add the 5, and in the 4 add the 2. Yeah, okay. Now we should calculate the entry grades. I think that is the right translate, but the entry grades, what means that is basically how many elements have in this. For example, the 0, the grade is 1 0 2 0. Sorry, this is not, it's not 0, it's 1. How many elements you have here? 1 1 2 1. Yeah, now the next that is for create an array with this of the t size, for example 7. 1 2 3 4 5 6. Okay, 0 1 2 3 4 5 and 6. And next to, we need basically, if the 1 appear here, increasing 1. This is an array of integers. Increasing 1, the 0, the 3, the 0 again, the 2, 2 and 4, and the 5. Oh, I forget the, no, it's, this is 5 and 6 because it's 7. Yeah, and the next that is this. Okay, now to, okay, let me check the 0. Let me do again. Okay, we have the, in the 0 appear the 1, and here 0 and 3, sorry, here in the index 1 increase, in the index 0, in the index 3, in the index 0 again, in the index 2, in the index 2 and 4, and in the index 5. Okay, now having this matrix, then next is that get all the, in this case, index, or get the index where the number of elements here is 0, yeah, or the grade in this case is 6, yeah, and use a queue for this. Okay, now having this queue is a while, basically meanwhile, or while the queue is not empty, or the queue, sorry, contains elements. Okay, you can get this node, and it's equal, in this case, this node, this is delete of this, and now is that get the register here, yeah, for example, is basically the 6 contains only the 5, and remove in this array, in the position 5, 1, for example, 1 less 1 is 0. When happen this case, when it's 0, we should add this index in this, or this, yeah, this item that is the 5 here. Okay, and this is complete. Now move with the next is the 5 in the queue. Okay, now is the 5, and do the same operation. Here is the 5, and this is the list is 2 and 4. Okay, in the 2 we need to remove 1. Okay, we have 1 element, don't happen nothing. But in the 4, if we remove this, is transformed to 0. 1 less 1 is 0, and we add the 3. Okay, and sorry, I forget, we need to add these values. Even let me do again, because we need a list here with the result of the this problem. Yeah, this is the result, and we start again. Okay, we have this, and now is get all the values. Okay, I need to come back more because I delete a few values. Okay, it is 1, 0 and 3, 0, 2, 2 and 4, and 5. Okay, now is get the index that have the grade 0 here. In this case, it's only the 6. Yeah, and okay, we need to remove the 6 here. Now it's equal 6. This is removed, and it's add here. Now the 6 have the 5. Okay, in the 5 we need to remove. This is transformed to 0. Yeah, and is 0 is add here, and that's it. Now move with the next. The next is the number 5 here, and 5 return 2 and 4. In the 2 we need to remove 1 element that is here, and in the 4 is remove 1 element. is transformed into 0. Is 0 means that we need add in the queue. Oh, but previously, sorry, 5. Now 5. Now we need to go to we complete this, and the next element in the queue, in this case the only one, is the 4. Okay, now let's remove here. 4 have the values of only 2. Okay, in the 2 we need to remove 1. 1 less 1 is 1 less 1 is 0. Yeah, means that we need to add here, and this is complete. And is add the 4 here. Sorry, I forget this. Now the next that is the 2, is remove it and is add here. Now the 2 get the values of 0 and 3. The 0 remove 1 is still in 1. And in the index 3 remove 1 is convert to 0 and is add here. Yeah, and this is complete. Now the next element in the queue is the 3. In this case the 3. The 3 return 0. Yeah, the 3 is at here. 0 is here. 1 less 1 is equal 0. Means that we need add in the queue. Okay. Here the 0. And this is the 0, and yeah, and that's it. Now the next is the index 0 is removed of here and is at here a 0 and is at here 0. The 0 return 1, and we remove 1 of this. In this case is 0 and is at here, and this is complete. And now the last is the 1 is removed, is at here, and basically the 1 return nothing. And in this case, when this is the result, we need to take first the 6, next is the 5, 4. This is the order: 6, 5, 4, 2, 3, 0 in 1. Yeah, and basically what is the way to detect that, for example, when you have 1, 0 and the other is 0, 1, that is a cycle. Basically 1 depend of the 0 and 0 depend of the 1. Yeah, it's a cycle. Basically this the size of this element is different to the n. In this case, for example, is 7 because contains 7 elements: 0, 1, 2, 0, 1, 2, 3, 4, 5, and 5 and 6. Yeah, and well, this is the idea behind the can algorithm. Oh, sorry. Okay, now I will try to do here in code. It's my first time after to learn about these algorithms that I try to resolve this problem, because in the previous transmission I tried to resolve using the DFS and one stuff, but works in a few cases but not in all. Okay, now for this is basically this: find the order of gate and course. Okay, we need a map, hash map. Even I think that it's not necessary create an extra function, because don't use the recursion, use basically a while. But here is hash map, and I remember that who mentioned that, I don't remember the username, but someone mentioned that with BFS, and essentially is this. But well, hash map, in this case the first is integer, and next to is a list of the integer elements. Come on, integer map, it's equal new hash map. Yeah, now here. okay, I need declare, I need here integer result, it's equal new int, yeah, of the size the num course. Now next two is okay, let me remember the pseudo code. Okay, is fill this integer I it's equal 0, meanwhile I it's minor to num courses. Is basically fill this map with the I think that we can improve this code, but let me do first in this way. Map dot put new array list, yeah, basically this. And next two is now for each this matrix array, double point here, integer a it's equal array in the index 0 and b in the index 1, and next to is map dot get, if in the positive way is basically b add a, okay. And okay, now we have filled. The next is get all the nodes that have entry grade 0. And I need a queue. We need a queue here, queue of the integer q it's equal new linked list, yeah, and here it's a for that for each in this case, okay, we need the entry grade 0, but for this the first is for each this map, yeah, is for, well, basically it's integer I it's equal 0, and when I it's minor to num courses I plus plus, and here is result, no, this is wrong. This is not the result, this is the grades, yeah, grades, grades in the index I no, here is a 4, that here we need get the elements in the map, for example integer n map dot get I, and in this case is grades in the index n plus plus, and now basically here is integer this, yeah, and if grades in the index I it's equal 0, means that we need add in the q dot it's add or append, I don't remember. Offer, well, the only difference is the behavior here, the between add and offer, and here is I, okay. And next soon, okay, we have this, now we need a while, and meanwhile q is empty but in negative, in this case is node integer, in node it's equal equal dot remove. Let me check if it's right. It's removed, yeah. Remove, and next to is okay. Now here appear the okay. Let me use a list of the integer. No, I think that I can return result number course integer index it's equal 0, yeah, and mention here result in the index node no in the index plus plus it's equal node. Basically, it's the order. This is the first, the second, whatever. Okay, now the next stat is a for, because we need to get all the values. Integer n map.get node, and here is before the if is say grades in the index n less grades in the index n less and here is if this equal 0 is q.add n, yeah, and here basically it's only the validate if index it's different, no, even no, it's minor to the num of course less 1 because it's an index. Return new int yeah, other case return result. Okay, let me check. Okay, here is increase the element if the index is equal to 0 is add here. I think that even here if the queue is empty, well, don't execute this, the index is different. Okay. Come on, where? I think that is linked list. No. Oh yeah. Yeah. Okay. Now let me check another. Okay. This is the cycle. Oh, nice. Now the next that is the is this, and is 800. Okay. Okay, I think that I can try to test this. Awesome. Now let me publish here in my Twitter. this in is course description and submission is this solution is can algorithm is this can algorithms scan algorithms solution using can algorithm Java. Okay, and okay. Now I will, before to check the other solution or the other solution, let me try to improve this solution, my solution. The first point is that I think this is not necessary. Uh-huh. Or we can I think this is not necessary because basically zero one here leetcode, come on. Okay, if here map contains key but in negative that is being is add. Okay, now for search the okay, this is for fill the grades, but I think that here I can avoid this and put here asking after the 4 if grade in the index the index I no no, I think that I can have this or remove this, sorry. Well, basically it's get or default. This is new array list. In here. What? Sorry, it's negative. Get or default new array list. Okay, and now let me add more text. This, the other is this, that is 800. Okay, the next is this, that is 4. Okay, I think that works, but let me check the last time. AMP I think that I can q dot add, yeah, for not for each of the elements, and only for each the elements that never appear here. Yeah, even I can import this. No, no, no. Uh-huh. Yeah, I think that I can submit, and I think that was better the other solution. Let me check here. 9 seconds. Well, it's very similar. Can solution. No, I think that I will update my previous solution with this. Edit. Oh no. Here. Okay, now let me check this solution. This is DFS. This is the other option, but this is using colors. And the other is new node in degree. Yeah, that this is not in degree. Why is calling it this way? Because in essential is the yeah, is a can algorithm. Yeah. Okay. Let me check how many. Okay, we are very near to. We are close to 300 problems. What is the problem of today? Largest number. Given a list of the non-negative integer nums, arrange them such that they form the large number and return it. Since the assume may be largest, return the string instead of an integer. Okay, well, here for example, I detect a pattern that when it's only try to search the elements, for example here, I'm not sure if it's the answer, but I noticed this pattern. For example, the elements with one digit is 3, 9, 5, and even if I sort this element, I have these values: 3, 5, 9, 30, 34. Okay, now the elements with one digit is basically the answer, 9, 5, 3, and next to is 34 and 30. This is the answer. No, this is wrong. Is 9, 3, 34. Okay, no, I was wrong. I confused this. Yeah, in this, I don't know. Interesting. Well, thanks for following this transmission. I will continue tomorrow.